Hi everyone, it's Ollie from flightcomp, and we're going to do another quick how-to video on the Vertigo. Today we're going to be installing the rudder horn and connecting up an elbe here on the carbon fiber push rod, and we will also be working on the servos, installing the servos onto the boom. So let's get going. The first thing I've done is just slip the rudder onto the boom and made sure it's fully seated and flush back here. You don't need to put the elevator in, just make sure that it's not sitting in here crooked. And I've put a piece of masking tape on the rudder to help me mark up where I'm going to make my cuts in the rudder for the control horn. So I'm going to draw up where I'm going to put the horn right here, and then I will get back to you. Okay, I have this square on the rudder, and it's lined up with the hinge. And it's basically centered on the carbon fiber push rod, and I'm going to draw a line there, and that'll allow me to measure up and mark the location of the horn. So I've drawn a line with a pen just dead center on the carbon fiber push rod, and it's perpendicular to the hinge line. And now what I'm going to do is measure up about 2.5 or 3 millimeters and draw another line, and that'll be where I place my control horn. So I've drawn a second line. I actually just put it 2 millimeters above the first line, and then we're going to mark the length and width of this control horn and draw it out with the pen, and then we're going to cut that out with a very sharp X-Acto knife. Okay, we have our rectangle drawn out here for the control horn, and basically this L-bend on the end of the push rod is going to sit like this. And you don't want to put this horn too high up to where there's very little engagement on the L-bend. You want to have the L-bend slid up a good distance through the horn. That way there's no possibility of it accidentally deflecting and slipping out of the horn. So we're going to cut that right there. Let's get our X-Acto knife and cut this slot out. There we go. We've basically cut away the carbon fiber skin, revealing the foam underneath. Now, instead of going at this with the X-Acto knife, I'm going to switch over to a thin file and start working away at this foam. Now, when you use the file or the knife, you want to use gentle pressure and make sure that you don't puncture the skin on the opposite side of the rudder. So just go very slowly and just work the foam out. Alright, after you've worked the foam out of the file, this is basically how the horn should sit in the rudder. We're very, very close. What you want is this hole to be basically over the hinge line. We need to move this forward a little bit, so I'm going to file in this area a little bit and move the horn up. Okay, I've moved the hinge forward a little bit in the slot, and I'm very happy with the way it fits. I'm going to leave the tape on here during the bonding process while I glue it in with some epoxy. So the next thing I'm going to do is just pull the horn out and scuff it up really good with some sandpaper, and then we'll mix up some slow cure epoxy with a little bit of microballoons, and we'll get it glued in here. Alright, I filled up the channel I made with some epoxy and microballoons, and I've scuffed up my control horn, and now all we have to do is put it in place. So we'll just slip it in, and we'll make sure that it's where we want it. And make sure it's pushed forward all the way. And then I'm going to just take a Q-tip with a little bit of rubbing alcohol and just clean up the excess. Like this. And then when this is partially dry, I will lift up the masking tape and we'll have a nice clean installation of the control horn, but that's basically what it should look like when you're all done. Okay, I'm getting ready to attach the elbe to our carbon fiber push rod, and to do that I'm going to make a coupler, which I have here, out of some stainless steel tubing. You could use brass or even hollow carbon tubing if you don't have this. The tubing fits pretty tight on the carbon and is slightly loose on the elbe. Now in preparation, I've sanded the carbon rod at the end here and put a little point on it. I have actually notched parts of this elbe with a Dremel tool and a cutoff wheel just to give it a little more bite when I glue it in. And I've also sanded this with 80 grit sandpaper. On the coupler, I've actually put a few notches on each end to allow the glue to get a better bite, and I've also sanded the outsides down a little bit. And I'm going to basically epoxy this together or use super glue, I don't know yet. And to tighten up the fit of this part into this coupler, I'm going to wrap a little bit of Kevlar thread around this before I slip it in. So I'll get on with assembling all this stuff. Okay, I've wrapped the end of the elbe in some Kevlar thread really tightly to take up some of the slack, and I'm going to simply saturate it with some super glue or CA glue and slip it into the other end of the coupler. Alright, here is my finished elbe on the end of the push rod. Now we'll put this guy back into the fuselage, and then we can move on to the servo installation. Okay, we're getting ready to put the servos into the boom, and here I have a previous model that I've already built. I have two BMS 115 HVs mounted in the boom. They're both in wooden frames, and I have just Z-bends connecting up the servos to the push rods, because this way I can use shorter arms and get more travel than having ball links, which are a bit more bulky. There's not a whole lot of space to deal with. So moving on to the servos. In this light model, I'm going to use a KST X08 for the rudder, which is right here, and a Bluebird BMS 115 HV for the elevator. Just to be safe, you might be able to get away with an X08 for the elevator as well, but I'm just going to be safe with this guy. Now I've mounted these both in RC Solutions wooden frames. These are super light, really high precision wooden frames made in Switzerland, which is kind of nice because everything these days is made in China. And what I've done is just taken a little piece of plastic, scrap baggie, and cut a square and put it in the tray before I push the servo in, as you can see here. This will keep the servo from actually sticking or bonding to the epoxy when we mount these in. Now to prep this frame, I have ground down the back of the frame substantially on the back side. It broke here, but that's not a big deal. Once it's glued in, it's going to be 100%. So I've really ground down this back edge of the frame and sort of rounded it. And the idea is that you want to get it to fit really tightly up against this side of the wall, because the servo doesn't have much room on this end. So you want to move the servo as far back as possible. And that's why I removed and ground down the back part of the frame. The X08 doesn't really need that because it's a lot narrower. But I did make a little sort of relief here for the nut, so I can get a little closer to the nut. And I've really scuffed up and sanded down the areas that we're going to be bonding really well to ensure that we get a good bond. And I'm just going to mix up some epoxy and get these servos glued in now. Okay, we have some epoxy laid down, and this is thickened with a little bit of microballoons and a little bit of Cabosil. Not too thick, and then we're going to put our servos in and clamp them down and then let them dry, and then we can move on to making the Z-bends to hook up all the controls. So here are my servos installed and clamped, and then we'll just set this aside and let it cure overnight. Now we have the servo trays installed and the resin is fully cured, and you can see they're in there quite firmly and securely. And then I've gone ahead and made my L-bends and sleeves for the push rods. As you can see, I've put some notches in the L-bends, a few going all around the rods, and I've also put some notches in the sleeves, some holes, just so that the glue has a stronger bite when I put everything together. Now I'm going to install everything in here and mark the push rods where I need to cut them and then trim them up and get everything installed. Before we can hook up the servos to the push rods, we need to make sure that our control surfaces are centered and fixed in place so they don't move. So I have my rudder linkage hooked up, the elevator linkage is hooked up, and I've just put some masking tape on the surfaces to make sure that they don't move, they're fixed, and they're pretty well centered. So now we can move on to the other end and hook them up to the servos. With the tails taped in place, I've attached my L-bends and just marked where they end on the carbon rods. Let's see with this little gold marker. And then I'm just going to cut these off with a cutoff wheel and then do a little bit of sanding to smooth them out, and we're ready to attach these together. So I have my L-bends in place with the sleeves and the couplers, and I use JB Weld to bond everything together. And I've just simply folded up some cardstock or thick paper and wedged it in against the fuselage and the push rods, just to keep everything off the sides of the fuselage while this is curing. And this basically completes the setup. We'll let this cure overnight, and then we'll go over the servo horn lengths and the wiring, and then we'll finish up the servo and the tail assembly with the boom. Okay, so everything is hooked up now and the servos are permanently installed. I have all my L-bends done up and the JB Weld is fully cured. I've used a little bit of tape here to secure this wire to the top of this servo. And then we have our leads. Now you can just use some extensions off your receiver and plug these directly into some female ends. But what I'm going to do is cut these leads down short a little bit, try to save some weight on some wire, and I'm going to use a 4-pin Dean's connector. So I'll solder that Dean's connector up to this, and that'll make it a little difficult for me to swap servos if I need to swap a servo quickly at the field. But what I think I'll do is I'll just make up 2 other servos with the same connector ready to go, so if one of these servos has a problem, I can just pull both of them out and put 2 new ones in. Or you can make up a little harness like this if you want, or you can just plug the ends of the servos into a 4-pin Dean's, and then you only have one connection to play with when you put the boom onto the pod. Okay, quick note on the servo arms. A good length for your rudder servo arm from the center of the output shaft to the connection point, whether it's an L-bend or a ball link, is 5.5 to 6.5 millimeters. And that gives you almost full range of travel in the servo and full range of travel at the rudder. So you get more power and precision out of your servo there. And then for the elevator, 6.5 millimeters to 7 millimeters on your servo arm length to get the most travel out of your servo and the most travel out of the elevator on the back of your model. Alright, so I've soldered on my Dean's connector, 4-pins Dean's connector, just to make things easier for me when I assemble the model. And that concludes the servo installation on the boom of the Vertigo F5J. I hope you guys found some of this information helpful. You could, certainly apply it to different models as well. And thanks a lot for watching, and I'll see you in the next one.